All right. Welcome to our Friday Tech Talk. My name is Forrest. I'm from Job Placement here at the Tech Academy. Today we're joined by Trevor and Jen from In Time Tec in beautiful Treasure Valley, Idaho. They're going to share us little inside secrets into a successful career in software development and some, how to land a successful career. I won't take up too much of their time. I'll let you guys go ahead and take it away. At the end, we'll open it up for some questions. So if you have any questions, feel free to hold them off until the end or include them in our in the chat bar located in the top right corner. But without any further ado, go ahead, Trevor and Jen, take it away.
Awesome. Thanks for having us. Looking forward to these presentations. Is always a highlight of my day. So, like you mentioned, we're with In Time Tec. We are a staffing augmentation company here based in Boise, Idaho area. And what we do is we have a blended model where we're able to spin up teams of developers in almost any area of development, SDET, DevOps, standard development, mobile development, and have them augment and enhance teams of our partners. So that's kind of like the day-to-day of what we do. I've been here for about 2.5 years and started as a software developer and got my start in software development from a boot camp, a local one here in Boise, and just pursued it ever since. I've since then moved from development day-to-day to now I'm doing technical account management, so not quite as much development as before, but still very close to the code, which is the part I love. So I'll hand it off to Jen, and she can introduce herself, and we'll go from there.
Hi, everybody. Can you hear me okay? Awesome. So like Trevor said, my name is Jen. I've been with In Time Tec for just over a year now. I graduated from Boise CodeWorks just over a year ago, and I am an SDET, a software development engineer and test. So that's what I'm up to.
Excellent. So we'll just jump right into the presentation, and I do have the chat window open, so if you post your question in there, we'll jump to it when we get a chance. Let me get there we go. Is everybody able to see that?
Looks good.
Excellent. I'm going to have to figure out how to. I'm going to have to stop sharing for just a moment because I need to get my share window onto my other screen so I can see both side by side. Okay. And I think I need to share again. Yep. Okay, there we go again. All right. Oh, shoot. Out of here. All right, so it's not letting me have my presenter and display slides, so let's just go here. All right. Today we're just going to share with you some of our tips that we have found super helpful for us to become successful in our jobs day to day as software engineers after we graduated from our boot camp. And really what we learned in our boot camp, and the most important thing that we learned was the ability to teach ourselves how to code and how to learn how to code from the boot camp. Yes, we learned languages. Yes, we learned frameworks, but the most important thing is in software development is that you continue to learn because those same languages and frameworks are evolving. New ones are coming out. Different ones may be popping into your projects and the like. And so this slideshow is really heavily based on that, but also is going to cover some of the kind of foundational things that you want to be thinking about on a day-to-day basis and project-to-project basis to really set yourself up for success. So just real quick, In Time Tec again, we are a global software services and products company. We build partnerships with other companies that are long-term. Our shortest ones are typically a year. We really aim for multiple year partnerships where we're with them all along the way, helping them achieve their goals. And we have a business model that allows us to deliver immediate ROI with these services. And we truly believe that you shouldn't pay until you see ROI. And so that is our commitment, is that until you see that ROI, you don't pay. And if any time during the partnership you don't see the ROI that you're expecting, you don't pay. And it's a conversation that we have with our partners. And why do we do this? We create abundance, and we just so happen to do that by developing software. And that's what we're really, truly about. Our services, since we do have multiple partners across all different industries and aspects of software development, we have opportunities in almost every area of software engineering available. Data science, software, platforms, cybersecurity, UI, UX design. We do some consulting. DevOps is becoming increasingly important, and as is mobile development as well. So on to the meat of the presentation. What makes a successful software engineer? To develop this presentation, we explained it to Rubber Duck, and he didn't seem to understand. So that's okay. He's a duck. But has anybody else here used a Rubber Duck to try and talk through a bug in their code before, or a bobblehead, or just something? Jeff, I see you raising your hand. That's kind of first and foremost. One of my best tips that a lot of people kind of forget about is just talking it out, vocalizing your problem, and moving through that solution, even with yourself or some inanimate object, has yielded me some of my most effective breakthroughs of bugs that have stymied me for days. So yeah, first and foremost, have you tried explaining it to the Rubber Duck? And Jen.
All right, talking about writing clean code. So you see the graph here on the left-hand side. Oh, it went away, sorry. On the left-hand side, you see a percentage of defects created and the cost to fix a defect, and you see that the cost dramatically increases later into the development cycle you get towards the testing phase. So you definitely want to spend a lot more of your time making sure you're writing clean code the very first time and testing it as well before passing it on and raising your pull requests. You really want to make sure it's readable and it works the way that it's supposed to be working. Once you get into the testing phase and you're seeing a lot of defects, it not only does it cost a lot of money, but it costs a lot of trust between yourself and stakeholders. So definitely just spend more time in the coding area with testing rather than later, and it'll pay big in the long run. And this is just a fun little cartoon of the amount of WTFs in your code. If you're finding yourself writing code and you're testing it, you're in your console or your dev tools, and the amount of WTFs that you're coming across, it's a sign that you're writing bad code or spaghetti code. And so the more you can write clean code as you go, the less WTFs you run into, and it just makes for a better experience for everybody, including yourself. So a few terms that show, your code is bad. It's a mess. It's spaghetti code. It's brittle, nightmare. You're looking for good code, which would be being clean, elegant, expressive, and it reads like text. There's only one place to make a change, and it's easy to maintain. All of those are also features of, making it really simple to pass off your code to other developers. They can jump in, know what's happening, and it's, like it says, easy to maintain.
All right, so who's heard of the Hippocratic Oath that doctors take? Is everybody familiar with that? Libby, I see a hand raise. All right, Rick, or Forrest, I see a hand raise, Rick. Excellent. Hippocratic Oath is do no harm. And, while that's embedded in the medical field, it's also very relevant for software development field. The code that you write into an existing code base should do no harm to the code base. And harm can be described as, of course, breaking it in the most easy to recognize sense, creating a bug, but also some of the less obvious ways that it does harm to the code base is breaking away from the code base's design pattern, making it less easy to read, introducing new patterns into the code base that weren't there previously. And that one's a little bit fuzzy because you can introduce new patterns if it's with the, conversation with your entire dev team that, yes, you want to introduce that pattern. But those are just some of the smaller ways that new code can do some harm to an existing code base. To prevent that, you kind of want to develop some of these habits. And I'm not going to read through all these line by line, but there's a couple I'm going to point out. The first one is the top bullet is the most important one. Code must be clean, well-written, easy to maintain, and easy to read. Super easy to say, super hard to implement. But in order to start your path towards implementing that, we always highly advise to read Clean Code by Uncle Bob and implement the theories that he presents there. And then also discuss with your senior devs, what are the best practices for that company, and implement those as well, because they will change from company to company, sometimes project to project, but hopefully not that often. Company to company is pretty often, project to project, that's kind of an indicator that there may be some underlying issues that need to be addressed in that company to ensure that developers can jump from code base to code base within a company and have a relatively good idea of where to look for certain things like global variables, repository patterns, stuff like that. Third is TDD. We'll talk about that later. Jen will cover that. And then the last 2 points I really want to point out is bake quality in. As Jen was mentioning before, it's so much easier to write clean code the first time and have that quality from the very get-go than it is to write until it works and then ship it and then try and come back and make it better for multiple reasons: time constraints, other code that gets written into it, familiarity with what you were doing at the time are just a few of the items. And then the final point I do want to point out is the Boy Scout rule. So Boy Scouts have a credo of leaving the area that they were participating in a better shape than when they found it. Same with us. We should leave code better than when we found it. And that can mean a couple of different things. You could be in a code base writing a specific method, function, or feature, and see that the method that was written above where you put yours in has some, really bad naming practices, like they're using single characters or misspellings or something like that. Go in and fix it. It takes you 5 minutes to rename a variable from I to integer or increment or something like that to make it more expressive. And it just makes reading the code much easier. And we really do spend a lot more time reading code than we ever spend writing code. It's about a 10-to-1 ratio when you do the math. So here are just 3 books that we really go through here at In Time Tec. We have a learning track called Learning Code, which covers clean code. And then we have other learning tracks that go over and read through Clean Coder and cover that topics. And then we do have architects here that go through clean architecture as well. All 3 books are written by Uncle Bob, or Robert Martin, as is his given name. I suppose the way you'd say that. And I just encourage you to read the table of contents of each, probably starting with Clean Code and Coder. Clean architecture can typically wait a little bit. Just read the table of contents and see which one applies to you most. Clean Code is about writing clean code. The Clean Coder is about being a professional software engineer. And there's a lot of little snippets in the Clean Coder that can really help make your first engagements and really any engagements as a software developer go more smoothly, be more productive, and have less conflict, potential conflict between yourself and like a product owner or a scrum master or stakeholder. So highly, highly advise at least Clean Code and Clean Coder as soon as you can have some time to read through them. A couple other books, just real quick, that we have on hand here at In Time Tec. Code Complete is considered one of the best practical guides to programming. So Clean Code and Clean Coder are kind of a little bit more theoretical and practices to implement. Code Complete is much more technical and like, this is how you write a function. This is, the style that you should maintain. And then practices of an agile developer just kind of helps you prepare to be in that Scrum/Agile environment a little bit more. Any questions so far? I just want to pause real quick, open it up.
You read The Pragmatic Programmer?
Yeah, and I've read about halfway through that one. That's also an excellent one that I would recommend as well. Yeah.
I just picked it up recently. I'm just curious your thoughts on it, if you liked it.
I did. I found it really useful to kind of help format my headspace for writing code. Because it does take a certain headspace to really write good, clean code. And Pragmatic Programmer really kind of helped me implement habits and just kind of what I should be thinking about as I write code. Let's see, and then just a couple more. Software engineering has changed in the last, decade, maybe 15 years. May sound like a silly statement, but back in the day, it was very much a kind of a lone wolf style of job where, you're a software developer and you're sitting in your cave and you're just left there to sling code. And nobody else really knew what you're doing because you were the coder and nobody else was. It's very much not that anymore. And especially with In Time Tec, where we are partnered with other companies, every single developer of ours also has to have a level of people skills because you're an advocate for In Time Tec, with your partner. And then you're also an advocate for the partner with In Time Tec. If there's anything that you see on either side of the business going on, you need to be able to communicate that. But it's still very prevalent as well, just being a software developer in any company, is you need to be able to concisely and effectively communicate your ideas, your timelines, your concerns about what's going on in the project, and just communication in general. So these are two that are pretty helpful. I haven't read soft skills, but it does fascinate me because it legitimately covers topics from like your career to marketing yourself if you want to be a freelancer, how to learn programming, how to be productive, to like how to manage your finances and how to maintain your fitness as a software developer, because they're all very important aspects of maintaining your health and wellness. And I'll pass it on to Jen.
Thanks, Trevor. One thing I also want to mention about picking up some books and reading them is there's a big difference between sitting there and reading a book, reading through an entire book, and actually reading it and implementing it and practicing it. So one thing that's really helped me is just reading a chapter or even two a week and really diving into some code and seeing how I can implement some of those concepts into code that I've written. So there's really no rush in reading through any of those books. Take it slow and really implement what you learn. Moving on here, this is W. Edwards Deming, and we cannot rely on mass inspection to improve quality. So he is a huge advocate for business quality. And one thing to mention about this, I remember thinking back to one of my first commits and just shaking my head, and it was terrible. It was awful code. It didn't work the way that I wanted it to, and my lead saw it. So you really want to make sure that you're in there and you're testing what you write. Take the time to test it, to write it good the first time. Even if that means you go back to your lead and say, hey, I need an extra day before I can commit this to really test it. That's going to really build trust between you and your peers. So we can move on to the next one. Testing. So this is really more my realm. There's just testing doesn't have to happen at the end of development, and it shouldn't. It should really you should use the term shifting left and moving all of your testing into the development process. It provides extra security, automated checks, and documentation as well. And I'll cover a little bit more of that in the next slide. So test-driven development. There are so many benefits with practicing test-driven development. One of the major ones is it provides documentation for what your code is supposed to be doing. It's very readable. And so when I jump into a new code base and I'm trying to learn it, I would go directly to those tests that are written, and I can see exactly what each function is doing. And it's just really a simple way of providing that documentation. You get fast feedback. It's great for regression. So if you were to write a function and it breaks your previous tests, you know that there's something wrong with that function that you just wrote. Let's see. It supports a clean interface. It makes tests or development just your class is small, so you're only writing code based on what you write your test for. You're not writing all this extra code. It keeps things clean and elegant, and it's a practice I would definitely recommend going back into the projects that you're writing and really implementing and seeing, how you can just practice test-driven development.
I want to chime in real quick. How many people are familiar with single responsibility principle? Has anybody heard of that? So the idea is that any given block of your code should only have one responsibility. A class should only have one responsibility. A method should only have one responsibility. A variable should only have one responsibility. And testing, and the reason for that is it's so much easier to spot a bug and debug when you know exactly the one piece of functionality that breaks. Because if everything only has one responsibility, there's only one place that you can look to find the bug if your login feature isn't working, because it's in your login function. And test-driven development and testing in general really helps enforce that, because it's easy to test a single responsibility function. It's really hard to test a function that has like 5 different purposes, because it's just like testing A versus B for which one's better versus testing A versus B through Z on which one's better. It really gets kind of convoluted, and as you can kind of think, becomes very difficult very fast. And the second part I want to add in there about the documentation that Jen brought up is, think about how long your longest function name was. Probably wasn't too terribly long. And, you try to make it expressive, but you can't write out as your function name, this function, takes a username and a password and verifies that it's correct and logs somebody in, right? That doesn't really make sense in your code base. But in a test case, you kind of can. Like, your test name can be that expressive, and that's where the documentation aspect of it really comes in handy. I've worked with multiple libraries where they had zero documentation on how to use the library other than their unit test cases, and that's what you use to figure out which like API calls you had to use to get it to function in your code base.
All right, and here we just have a graph that shows the time it took to code a feature and the defect density of the team. So although it took a lot more time to implement TDD, the defect density decreases drastically. So it's going to save you a lot of time in the long run. and there's really Trevor really summarized it all really well with test-driven development. So I think we can go ahead and move on to the next one. And this one is just a video. It will demo the creation of a test. So I would recommend, we're going to give you guys the ability to watch this video when you get the slide deck. So I'd recommend just watching through it and kind of getting your hands into some code and kind of coding along.
Right, any questions about testing before we move on to some other topics?
I was going to ask what resources you had for learning TDD. Obviously, that video is kind of a demo for it, but do you have anything in specific that like you would highlight as a good resource for learning?
Jen, anything on your end?
I don't have a book off the top of my head for TDD. I can definitely look into some. I've been more in the automated test realm, writing end-to-end automated tests. So I have great books for writing an end-to-end automated test. It's one by Arnon Axelrod is a good one to read, and I can post in the chat here what the actual name of it is, but it's a really good book to get your hands into actually learning how to write your first test case, how to make it readable, and it kind of goes chapter by chapter, and that's exactly what I've been doing. I've just been picking it up, reading one chapter, and then following along, and it's just kind of a how-to book. So let me find the name of that, and I'll get it posted in the chat for you.
Thank you. That'd be super helpful.
Yeah.
And we do have some more book recommendations at the end of the slide deck for people to look into. And then in terms of like TDD specifically, there's not much to it. If you just need to learn how to write unit tests, that's the most important thing. And then you can look at a couple of YouTube videos or blog posts about coding in the TDD style. And that'll kind of show you how to do the cadence, because it really is a lot of blog articles and people refer to it as a red light, green light cadence, where you write your test until it fails. So your initial go at the test is usually like just writing what it's supposed to test, and then it'll fail when you run it. Then you write just enough business logic to make the test pass. And then you write your next bit of testing for the next portion of the business logic, then you write just enough business logic to make that second test pass. So it's when you're looking at your console and you just see your tests being either red or green, that's the cadence that you're looking at. Write a test till it fails, make it pass. Write a failing test, make it pass. And just speaking of that, there is, so this list right here is actually from the pragmatic programmer, from Code Complete. And it has a whole, you can have the URLs right here. There's a whole bunch of basically checklists of what you should look at when looking at your code base and what you've coded, from like your comments to configuration management, your data types that you're using, everything in here. And you can see there is a test cases section of that. And I would be very surprised if there was not a little portion in there about unit tests and test development. Each of these checklists, this is the list of checklists, and then each of these checklists looks something like this. So this is the class quality checklist. And these are the questions that you should kind of have in your brain as you're both writing your class, and then especially when you're done, you have your feature developed, it's working, and you need to then review it for refactoring and quality. So does the class have one central purpose? And it's kind of back to that single responsibility principle. If your class is doing 15 different things that are not really related to each other, you need to break it out into more classes. Is it well named? Does the name describe that central purpose? If you find yourself naming your class like processor or splicer, or you're having a hard time naming a class and it's not just straight up login or password check, something like that, something very specific, concrete towards its purpose, likely you have too much going on in that class. So that's a great indicator. If you're having a hard time naming your class or your function, likely you're going to try and fit too much into it. All unrelated information moved out of the class, absolutely. And then does the class minimize accessibility to its members? That's also an indication that it's maintaining like a very narrow focus and there's not outside intrusion coming in, because if anything and everything can access your class, you probably have too much going on in that class, you know. The account creation class should not have access to the login class, because while they're related, they're separate processes that run in parallel, right? You don't need to know how to log in order to create an account, and you don't need to know how to create an account in order to log in. Does all that make sense? Any questions so far?
No, makes sense.
Awesome. So really it comes down to, actually, is this you, Jen? I don't have my notes up. No, this is me. We've said this a couple of times so far in the presentation. It's so much easier to build quality in when you start and not try to make it quality after you've been going at it. Because there's just so many fewer factors that come into play when you build it in from the very beginning. You know, one of them is the business side of things. As a software engineer, we know it takes time to build code. We also know that we need to build code in a certain time span to meet the business requirements. We also know that when times get a little bit squeezed, we may take some shortcuts to get that code to work to meet those business needs. And as we're doing this, we also likely know that those shortcuts are probably going to come back to bite us in the butt later down the road. And so if we build the quality in, that doesn't just relate to just the code that we're building. That also relates to building quality disciplines within ourselves to reduce those shortcuts. Because if you think about it, if you change your coding practices when you're under stress, say it's a production bug, say it's a tight timeline, and all of a sudden you're coding in a different pattern than you do on a normal day, is your coding pattern on that normal day the best way to code then? And if it is, then why are you changing it when you're under stress? Does that make sense to everyone? So building quality in not just to your code, but also to just how you approach your own coding practices is essential. When it does come to code, though, Jen will cover some of these checkers.
Yeah, style checkers, use them. I am most familiar with ReSharper, not really style cop. I haven't used that one, or JS Lint. But they're just going to give you extended IntelliSense abilities and really just kind of catch a bad code smell really early on and give you quick fixes if there are any. So definitely use them and learn from them also. So we've got those are some options for style checkers. And the next one we have some static analysis tools. So if you want to go to the next screen there.
Real quick, Jen, are you a tabs versus spaces person? Okay, good. Anybody who says spaces is better than tabs, use a style checker and switch it to tabs. No, I'm just kidding.
Could you dive a little bit into what a style checker is for those of us that aren't super familiar with you kind of touched on it a little bit, but like these are extensions, right, to like Visual Studio, right?
Yeah, do you want to cover that, Jen? Or you want me?
Yeah, I mean, go ahead, take it.
Yeah. So style checkers, as the name kind of indicates, this is more looking at how your code looks on the page than the actual content of your code. So within ReSharper, JS Lint, Style Cop, and anything like it, you can develop certain rules that will determine how the code is written, such as like you have a tab from a tab indent for your first line in a function. Your first curly brace is flush against the left side of the screen, and it helps maintain consistency across every page of your application and helps reduce individual developer preferences in their coding style. Some developers like to have the curly brace on a new line. Some like to have it on the end of the function name, stuff like that. And these style checkers can both check for it and also automatically format it, on commit, so that you don't even have to worry about it. You can code in whatever style you like to code in, and then as soon as you commit it, it will format it for the project. It also covers things. It can also cover kind of warning signs like too long of function names or too short of variable names. It can look at stuff like that, and just really helps maintain a readable code base so that your individual developer preferences aren't impacting the readability of the code base. Has nothing really to do with the logic of the code, just how it's physically written.
Thank you. That's super helpful.
Yeah. Oh, and we had one more, check style. I knew that little corner looked a little bit empty.
All right, yeah, and static analysis tools are they're gonna be very simple or similar in maintaining your code and keeping it clean. And what it's going to do is it's going to examine your source code, executables, and documentation to find problems before they even happen, before actually jumping in and compiling your code. Static code analysis is a method of debugging by examining source code, again, before a program is run. It's done by analyzing a set of code against a set of coding rules. Static code analysis and static analysis are used interchangeably along with source code analysis. So yeah, I don't really have anything additional to add to that one. Trevor, can you touch more on that one as well?
Yeah, absolutely. So this is one step more in depth of analysis. This does look at the logic of your code and can capture some more metrics like unit test code coverage. So it'll examine how many tests or how well coverage, how good the coverage of your code is by tests. There we go. And can actually even prevent a commit or movement through a CI/CD pipeline if there's not enough code coverage or if your unit tests are failing. So it's another gateway that can be used to maintain the quality of code and can, like Jen said, sniff out some of those code smells, such as functions that are written but never called. So why is a function written but never called? It can find blocks of comments that shouldn't exist. It can look into, depending on how you configure them and how deeply you configure them, it can look at like data flow as well and see that class A is manipulating data when it passes to class B, and maybe it doesn't want to do that. So it throws, it's not a level of warnings and control just to make sure that it's automating a lot of checks these days now to make sure that your code is maintaining quality and catches some of those things that may degrade that quality. These are a little bit more, you can see rest sharp is built into this one as well. It's a style and static checker. Sonar Creative is also a style and static checker, but most often used as a static analysis tool. And these are typically, style checkers can be run on commit. And even when you build the project in your own local environment, static analysis tools can also be run that same way, but typically if they are really heavy in the configuration, I've seen them most often run in like a CI/CD pipeline or a commit pipeline where you commit and then it'll run. So it can take a few minutes to run and before kicking you back some results or passing the commit. Any questions on those? Yeah. Most likely these static analysis tools will be configured and implemented by your company rather than like yourself as a developer. Style checker tools are the same way, but can also be implemented more at like a project level than like a company-wide level. I always have a sneaky one. I forget that I have those in there. That's one, and IntelliJ IDEA is one specifically for Java, just for reference. All right, on to you, Jen.
Yeah, this is just a funny little comic. Just one thing I can say about it is just to not fall in love with your own code. You're going to write bad code, and all you can do is just refactor and learn and practice. But just because you wrote it doesn't mean that it's good. So keep that in mind.
I really hope in about 6 months into your first jobs as software developers, you can look back at the code that you wrote during your boot camp and cringe a little bit, because that's what I did. I was about 6 months into my job, and I was like, oh man, I remember that app that me and my friend started in boot camp, and I was like, I really kind of want to pick that up and see what I can do with it now. And I opened it up and I looked at it and I was like, oh my goodness, what was I thinking? And that's a great thing to think, because that shows that you've grown, and that shows that your concept of what good code looks like has matured. So I highly encourage it. Like, you might cringe when you look at your old code, but that's great. That's an awesome thing to do. So yeah, definitely take a look back at your code that you're writing now when you're like 6 months into your job, and just see the difference that your experience has made. These are what source control do all you use in your boot camp?
Git and GitHub.
Git and GitHub. Excellent. So there's a variety of them out there. GitHub's great. They all work fairly similarly with different varying levels of functionality and robustness. I've personally used Bitbucket, GitHub, and GitLab, but they're all designed to do the same thing, and that is to, one, be a repo and a historical record of your code, and then some of the more robust ones can create platforms for you to have your code build and deploy to various servers in the CI/CD pipeline for DevOps. So just be familiar that there's others out there. Most of them will all use the same Git kind of commands, and you can also use GUIs for your Git as well, such as TurtleGit or SourceTree, which is a companion app for Bitbucket, but also works with all these other ones. And they just provide different ways for you to commit, pull, push, and resolve your coding conflicts. And I encourage that because when you work on a team, inevitably you're going to have some commit conflicts, because while we all try and work in separate parts of an application, there's going to probably be overlaps at some point in time, and being able to easily look at that conflict and resolve it before it reaches your repo and kind of like your master branch is so very helpful. It's also very useful to be able to do that in case you do develop a feature and push it, and it's peer reviewed and everything looks good, but then it gets into master branch or production or something like that, and all of a sudden there is a bug because there was like one missed variable or something like that nobody caught. It's so much less stressful to be able to say, oh yeah, let's just roll back the production branch to this commit over here, which is before all of my feature changes. Then we'll just push that back to the servers, and boom, my feature's gone, but so is that bug. So if you can make yourself comfortable with that kind of workflow in Git and these source controls, it's going to be very beneficial, especially as projects become larger and more complicated. And then a final piece of advice for that is, in all of your IDEs, there's always a build settings tab. And you can run static analyzers from here, but also I'd encourage you to treat warnings as errors. A lot of the time it's pretty easy to be like, oh, well, that's just a warning. The code still compiles just fine. I'm not going to worry about it. And 90% of the time that's fine. But if you can write even cleaner code that has no warnings, then it's just that much better, that much more stable and secure code than if you're allowing those warnings to creep in, because warnings can turn into errors if not approached at the right amount of time. All right. Who can fill in the blank at the top there?
Is it production?
This is a Scrum process. So in CodeCamp, do you guys practice Scrum and Agile in group projects?
We do, yeah. We have a live project that we do Agile and Scrum.
Excellent. Excellent. This is what this is the graphic that's given to your product owner and kind of Scrum master training. And it's the idea of creating, it's the model that's supposed to be constant productivity at a sustainable pace so you don't burn yourself out. Another model is Kanban version, where you just have a whole Kanban board of like to-dos, and you just constantly pull those to-dos to like in development, testing done. And that can kind of burn you out because you don't have any breaks. There's always, as soon as you're done with one feature, you move on to the next. But with Scrum and sprints, you might finish a feature in, the sprint is 8 days long. You might finish your feature and have it committed in 6 days. And then you have 2 days there to kind of breathe, maybe do some personal training, some personal learning, or pick up another ticket if there's one other that you really want to take on. But the idea is that the product owner or the stakeholder, the business owner, thinks about what they want, and they have a product backlog, which is this feature A, B, and C. And they just kind of toss things in there, and you plan a sprint around it. And your sprint planning really takes one of those features and breaks it down into its core elements, and then breaks those out into tasks. And each individual developer can take each task as part of their sprint. And that's where you create your sprint backlog. Is you have your tasks here, and then your active tasks here. So you have sprint executions, which is really ideally no longer than a month. A month is a really long sprint. The best length I've seen is about 2 weeks, and I've seen week-long sprints, and those are really tough as well, because that's a lot of meetings for a week-long sprint, because you have planning, and then you have like retrospective to see how the sprint went, what went well, what didn't go so well, what could go better. And doing those every single week is a little bit rough, but every 2 weeks, that's just about right. So your sprint execution has a hard set deadline where you're trying to implement the sprint backlog features and their individual tasks. And the idea is that you have a potentially shippable product increment at the end of every sprint. Not necessarily a complete feature, but a step towards that feature. And then you have your sprint review at the end of each sprint, where you are inspecting and adapting how that sprint went. Sprint review is where you're presenting what you built. Sorry, little tongue twister. Where you're inspecting, adapting, and presenting what happened in that sprint. Then you have your sprint retrospective, where you inspect and adapt your systems within that sprint to make sure that you're always doing the best possible system each sprint.
Can I make mention of that as well? There's going to be a lot of terms that are going to fly around, like Agile and Scrum, and just to kind of clear up any kind of confusion, Agile is the methodology, and Scrum is the actual process of delivering software in a continuous and quick process. So in the testing world, kind of to give you a real world example of being more agile versus being more waterfall, doing a lot of development and then testing afterwards, is that when you're in that more agile phase and you're testing alongside the sprints and the Scrum process, then you're really able to see, okay, this feature broke the whole system under test during this sprint, so we can go back and figure out exactly very quickly what happened and why it broke. Whereas the waterfall, you develop a lot, and at the very end you test it, and you can't really easily go back and see which feature actually broke it. So I just wanted to clear up a little bit of confusion that I had when I first got out of my coding boot camp.
Great contribution. Thanks, Jen. We are at 5 minutes till the top of the hour, and I want to be respectful of everybody's time. I'm fine sitting on for a little bit longer. Everybody else will. The next slides that we have are just some of those book recommendations that we have here in the office, but I really want to open it up to everybody and answer any questions that you might have about what the industry looks like, what working in it looks like, anything like that. So I'm going to go ahead and stop presenting for the moment. Like I said, you will have this slide deck to reference, so you can look at those book recommendations, but I really just want to open it up for conversation.
I had a quick question if no one else wants to jump in. I was curious, you used the term spaghetti code a couple times in previous slide. Can you go into a little more detail as to what spaghetti code refers to? Yeah, but I want to just clarify that a little bit.
Yeah, spaghetti code. It's pretty much an industry standard of code, then describing poorly written code. Just think about looking at a plate of spaghetti and trying to follow one noodle from end to end in that plate of spaghetti. How hard does that sound? Probably incredibly hard. It loops, it curves, all the spaghetti noodles look the same. And the same idea goes for code. So think about trying to follow data from like an input field on the front end of the website all the way to the database. And if it's clean code and written well, you should be able to very easily read, okay, it goes to here, to here, to here, to here, and it should be very hierarchical and step through, very cleanly and clearly. Spaghetti code is when that input field data makes it to the database, but it just kind of, loops around and maybe kind of goes back a bit, and it's just really, really hard to follow. So that's kind of what we mean when we're talking about spaghetti code.
Gotcha. That's kind of what I thought, but I wanted to make sure I wasn't thinking of something else.
Yeah, absolutely. Most of the time, spaghetti is appetizing, not in code. Great question. Any other questions?
Well, Trevor, I do want to say that is the best description of spaghetti code I've ever heard.
My last project that I was in, I was dealing with legacy software that was written in Fluent Spaghetti, and so I got very, very, very familiar with it, and never wish it on anybody else. So once you've seen a code base like that, the drive to write clean code is just so much stronger.
Yeah, it will definitely rack your brain. I am glad you brought up the Robert Martin with Clean Code. Those are great books. I read Clean Code. I do read them. But definitely that's a good way to approach software development. And the book is just, it's incredible. I use kind of an overview of that book whenever I write code. And I'm actually going to put a link in the chat. It's to a GitHub account, but it's somebody who posted the rules, and I use this every time I do development. So I'm going to add that to the chat. One question I did have, though, is for somebody who's just graduated a boot camp, what is your best advice for finding their first job?
Great question. So a couple of different things I'd point out for finding your first job, and then I'll pass it over to Jen for her input. But to find your first job, really think about what you want to be doing with your coding experience, and don't limit yourself to postings that are just full stack developer or front end developer or back end developer. The software world today is a little bit more convoluted than that. I don't think I've ever solely worked as a front end developer or a back end developer, regardless of the job posting I applied to. And there's so much more out there, such as SDET, such as DevOps, such as cybersecurity, that is still very much within that sphere of complexity, creation, and challenge that coding provides. but doesn't fit under that umbrella of full stack developer. And so they can still be very rewarding and growing opportunities. So definitely don't disregard them just because they don't say full stack developer. Then the second piece of advice that I have is make sure that you have your code base, a project that you're really proud of, and know it front end to back end, to be able to work through it and walk somebody else through it very quickly and concisely, and then be able to speak to some of the more complex pieces of it that were, either hard for you to implement, but you overcame that adversity and were able to implement it, or you're just really proud of because it was a tricky feature and you made it work, and be able to kind of talk through how you approached that tough feature. I do a lot of the interviews here at In Time Tec, and that's the first thing that we always ask from any college or code camp graduate is, show me some code. Show me what you've written that excites you, that you're proud of, and let's talk about it. And we do it, and it really gives a good idea of what your capabilities are. And if you're able to explain what you wrote to a third party in a concise way, then you're going to be able to write it. Then it just comes down to the language syntax. So that's kind of my two big pieces of advice. Jen?
Yeah, you really covered two really important parts. Coming from the first point you made, I started at In Time Tec as a SDET. So it had that QA role definition that I wasn't really looking for. And so I'm really fortunate that I went ahead and took the leap and jumped into it, because I am writing code and frameworks, and I'm working on a development project right now. So definitely don't close yourself off just because the top of it says QA, but definitely keep coding and keep practicing. I had one other point. Bootcamp grads, definitely, I mean, a lot of you are coming from a completely different career. So you're hungry and you're passionate, and that is something that does show in the interviews. So definitely use that, because a lot of people that are coming out of college, it's something that they've been doing, and they may or may not show that same kind of passion and that hunger. So definitely just lean into that a lot and keep practicing.
Yeah. One final thing too on for interviews specifically, we don't really use whiteboards anymore here as I sit in front of a whiteboard, but we don't use your typical whiteboard questions. They're useful, but they don't give a good scope of a developer's potential. So I'd recommend, know your typical FizzBuzz questions, be able to write out for loops with a whiteboard marker, but more importantly, if you get into an interview and they're assigning you a technical challenge and you've gotten into it and you're thinking, oh goodness, I'm not going to complete this on time, in code to a functional product. Always stub out your thought process of what you wrote, and then also what you were thinking of writing, so that the interviewer can get a really good idea of your ability to approach a problem and break it down into logical parts that you can then execute. I can tell you, I look a lot more towards how somebody thinks than the syntax that they can, put down on a board, because you can Google syntax. I mean, I've had to Google an if statement before because I was having a brain fart moment, and I was like, how do you write an if statement again? But I knew it's what I needed, and I could explain my exact logical thinking to somebody, and that's more important.
One thing that I do when I do coding challenges, kind of like, because I help folks land jobs, and I kind of have that same sort of thought process of like, if you can at least show your thought process, that goes a long way. I'll write out like my function, but I'll just have like a blank canvas, and I'll comment out what I think needs to happen at each kind of phase. And then I'll fill in the comments with like my actual code. So I'll like, break this into an array and then parse through the array for yada yada, and like writing out those comments first and then kind of filling it in that way. Do you recommend that as a decent process? Is that kind of in the same lines of like showing your process beforehand?
Yeah, that's a fantastic way to approach it, because it both shows, you know exactly the steps that you need to take. And and really shows that you know how to solve the problem. You just, maybe having a hard time with the exact way to write, how to parse an array. Yeah,
Okay.
excellent.
Cool. Awesome. Well, I think that's going to do it for us today. We really, really appreciate your time, Trevor and Jen. Thank you so much for being with us today. We learned a ton here. I'm excited to go back through that deck again. Are you going to send that my way so I can kind of distribute it to the attendees? Okay.
Yeah,
fantastic.
I'll send you that deck, another PDF, and then our job application for anybody who's interested. And then you can send out my email as well. And Jen, if you're okay with it, send out your email. For anybody who might have follow-up questions, they can reach out and we'll be happy to answer them.
Amazing. Thank you so much. I really appreciate it. Anything else you guys want to leave us with before we end it for today?
Congratulations. I mean, getting through boot camp is super hard. Know it full well. So, keep up your coding practices. Code on your free time if you want to. But yeah, just really be ready to show people how you think and don't get discouraged. This is an industry where there is a lot of competition, but you all have a lot of unique things to offer any employer, especially coming out of a boot camp.
Thank you. That's great. Well, thank you guys so much again. Thank you everybody for joining us today. And we hope to see you all at our next Tech Talk on Friday next week.
Thanks.
Thank you, everyone.
Thank you.
Great talk, Trevor and Jen. Thank you.